Hey guys, here's a video walking you through how to find the volume of a solid when it's revolved, when the region that it's created by is revolved over the y-axis. It's going to be a little different than the way we approach the x-axis version, but it's very similar to when we did area between curves relative to like the y-axis or vertical line. So step one, of course, as always, is just get a good picture. So let's just get a good picture here, something reasonable. And x cubed, so that's the one that goes kind of like this. And you could use your calculators if you need to, but some of these curves sometimes are uh, are familiar. So there's y equals x cubed, something along those lines. Y equals 8 is somewhere up here, not drawn to scale. There's y equals 8, y equals x cubed, and x equals 0 is just the y-axis. So this is the region that we're revolving. And we're supposed to revolve it over the y-axis, so it's going this way. So we kind of draw the reflection as best we can, and then realize this is the region that it would look like if it was just flat, but it's obviously three-dimensional. And this one's kind of looking like a bowl or something. I don't know, something along those lines. So step one, get a good picture. We got a good picture. We're realizing that we're revolving it horizontally, essentially over, horizontal. Excuse me, we're revolving it horizontally over a vertical line. And then here's the tricky part. When we slice this one, or it's actually going to look like this when we slice it. When we did relative to the x-axis or over the x-axis, something like that, the slices all looked vertical. This slice looks horizontal. The good news is the volume concept is still the same. We're still going to accumulate all of these slices. We're just going to accumulate them vertically. So we're going to start down here at the first one, and then we're going to go all the way up to the last one. But in order to do that, we have to identify what is the radius of each of these little disks. So if you remember, our formula for volume in general was the area of the cross section, right? In this case, our cross sections still are circles, so our volume is going to be pi r squared. In this case, though, it's going to be with respect to y. And now we got to figure out what that radius is. So we need to figure out what the distance is from the y-axis to the curve. And I know a lot of times people's instinct is to just say, oh, it's whatever the function is. Well, in this case, the function is, y equals x cubed. We're going to have to, that's going to give us sort of our heights, if you will, or our function values, going from the x-axis. If x equals 2, we can figure out that y equals 8. I need to know what happens if I plug in a y value. I need to know if I'm on a particular point here on the y-axis, where does that put me horizontally? So if y equals x cubed, we have to realize that, wait a second, we want this, essentially the inverse of this, we want the cube root of y, right? Take the cube root of both sides. This is going to tell us our horizontal distance from the y-axis. So again, if I know what y I want to use, I could figure out what x I have. If y is, say, 1, x would be 1. If y is 2, x is the cube root of 2. If y is 3, x is the cube root of 3. If y is 8, x would be 2. And we could actually figure out all of the x values, how far over we are relative to the y-axis using this equation. So kind of like when we did area between curves, we would sometimes need it in terms of y, so x equals, that's what's happening here. So our volume is going to be pi. The radius this time is the cube root of y squared with respect to y, so pi r squared dy. And now we just need to figure out our limits. Well, like I said before, we're accumulating these disks kind of vertically. So the volume of the littlest disk, or these tiny little cylinders, if you will, added up, going from bottom to top. So the bottom value for y is 0. The top value for y is 8. So this is going to be a volume accumulating from 0 to 8, adding up all these disks all the way up. And then at this point, you could just use your calculator. This one's actually not too bad to do by hand, but I always told you once we got to this part, we can just use our calculator. So again, we can't really type in y when we go to do this, but we can just type it in as is using x. The calculator doesn't care what variable you're using. 0 to 8. And this is going to be the cube root of y squared. So you can type that a couple different ways. You could rewrite this as y to the 2/3 if you want, or you can just write it as is, cube root. So here we go, cube root. I believe that's under math. cube root, there we go, of x, and then I'll square that. So there's the cube root of x squared with, oops, I didn't mean to hit that button. With respect to, in this case, we have to use x. Again, it doesn't really know what, it doesn't really care what letter we're using. We just have to make sure the equations are correct from 0 to 8, and I didn't put the pi in there. So I can multiply the pi after. I guess I could just do it here. And there we go. So it's about 60.319 is that volume. If I wanted to do it without the pi and just write it in terms of pi, I could have just left the pi out. This is going to be 19.2. Looks like it probably is exactly 19.2. It probably has some calculation, oddities going on at the end since of the way it calculates, but it's 19.2 pi. Okay, so there's essentially how you approach it. Try to get yourself a really good picture. Determine if you're using the y-axis or the x-axis or something vertical or something horizontal. And then your real key is to figure out what this radius is. That's going to be your key step. And then once you get there, it's really the same kind of process the whole way through. All right, hopefully that helps. If you have any other questions, be sure and let me know, and I'll see you guys later.